Welcome to the deep dive. Today, we're really digging into a specific but pretty powerful concept in the whole cloud native world. You've shared some frankly fascinating stuff on Kubernetes storage classes, and well, our mission today is to pull out the most crucial bits of knowledge from all that. So, yeah, let's set the scene. Applications, I mean, they need to store data, right? Databases, user files, logs, you name it. But in something as dynamic as Kubernetes, managing all that storage, well, it can get complicated fast. And these sources suggest storage classes offer a kind of elegant way through that complexity.
Exactly. Yeah, this deep dive, we're going to uncover what storage classes actually are and, why they're so critical for deploying apps today, and crucially, how they really work under the hood to automate and frankly simplify persistent storage. We should hit some real aha moments as we unpack this.
All right, let's break this down then. Foundational question first, I guess. What exactly are storage classes in Kubernetes? Our sources seem to define them as a resource, right? That describes different kinds of storage available in the cluster, enabling this thing called dynamic provisioning. And there's a neat analogy in the sources. Think of a storage class as a menu of storage options. So when an app needs storage using a persistent volume claim, a PVC, the storage class, tells Kubernetes what kind of storage to dish out. Like maybe 10 gigabytes of fast cloud storage, and boom, Kubernetes just sets it up. No manual fuss.
Yeah, and what's really powerful there are the key characteristics. First, that dynamic provisioning you mentioned. It really does away with needing to manually create persistent volumes, PVs. Kubernetes just spins one up automatically when a PVC points to a storage class. That's huge. It changes how developers even think about infrastructure.
Hmm.
And then there's the customization part. Storage classes, they define attributes, like performance fast SSD versus, say, standard HDD.
Hmm.
Or specific cloud settings, AWS EBS, Google Persistent Disk, whatever, maybe even replication rules. And this detail gets hidden, which leads to, well, abstraction. It hides the messy details of the storage system from the devs.
Makes their life easier.
Totally. And finally, reusability. One storage class definition can serve loads of PVC, so you get standardized setups.
Okay, to make this really tangible for you listening, let's think about some use cases from the sources. Say you've got a demanding MySQL database. Needs fast storage, right?
High IOPS.
Right, so a storage class can guarantee that. Or maybe a simple file sharing app. Doesn't need blazing speed, more cost effective. A different storage class fits the bill there. And the sources also really emphasize how they help with multi-cloud. You define these abstract classes, map them to AWS, Azure, GCP specifics behind the scenes, makes things more portable.
Yeah, that abstraction layer is key for portability.
So, okay, this leads to the big why. Why aren't storage classes just, nice to have, but actually crucial for modern Kubernetes? It seems to boil down to handling data, persistent data, in these really dynamic systems.
It's about moving from manual reactive work to something more automated and proactive. Dynamic provisioning, like we said, cuts down the admin workload massively, and that directly affects scalability. Imagine huge clusters, cloud environments, manually making PVs for every app. It just doesn't scale. Storage classes let Kubernetes handle it on demand. It enables things like, get off for your infrastructure. You declare the state. It happens. Plus, there's the flexibility across different environments. They support all sorts of backends cloud storage like EBS or Azure Disk, sure, but also on-prem stuff like NFS. So your apps consume storage the same way, regardless of where they run. That streamlines deployments. And admins can create these tailored policies, offer a menu like different performance, different costs, maybe different backup rules built in, and honestly, maybe the biggest win, a simpler developer experience. Devs just ask for a storage class in their PVC. They don't need to sweat the infrastructure details. Faster development, fewer mistakes.
Okay, so let's flip it. What if you don't use storage classes? What's the pain point? The sources seem pretty clear. Manual PV management would be, well, a nightmare. Time-consuming, error-prone, leading to delays, wrong configs, inefficiencies, especially in bigger dynamic setups. Sounds like a real operational headache.
Oh, absolutely.
Yeah.
Think about a real-world example our sources mentioned, like running WordPress in Kubernetes. Needs, say, 20 GB for user uploads.
Okay.
Without storage classes, an admin has to manually create that volume, maybe in AWS, maybe somewhere else, configure it, attach it. Tedious. But with a storage class, the developer just makes a PVC. I need 20 GB from the fast cloud storage class. And Kubernetes just does it. Provisions the 20 GB PV, maybe an EBS volume, binds it, done. The admin doesn't touch it for that specific request. It completely changes the workflow. Huge boost for speed.
Right, okay. So they're clearly vital. How do they actually work then? Let's get into the nuts and bolts. Walk us through that basic workflow. How does this orchestration happen?
Sure. It's actually quite an elegant process, this sort of automated dance. It
Hmm.
starts with the cluster admin defining the storage class itself. They specify things like the provisioner, that's the driver, like avs.csi.ads.com for AWS EBS storage, and parameters like disk type, maybe encryption is turned on, and importantly, the reclaim policy, delete or retain.
Ah, right. What happens to the data later?
Exactly. So you might define, say, a premium SDA class for your really fast drives. Okay, step 2. A developer creates a PVC. They just reference that class, premium SEA. They say, I need 10 GB and point to premium SSD.
Simple request.
Very simple. And that triggers the dynamic provisioning. Kubernetes looks at the storage class, sees the provisioner, and automatically creates a matching PV. Then it binds the PVC to the new PV. So for our premium SSD example, it would automatically create maybe a 10 GB AWS EBS volume, and that becomes the PV. Then step 4, the pod definition. It references the PVC by name. Kubernetes mounts that PVC as a volume inside the pod at a specific path, like data maybe. So containers in the pod can read and write. Think of a database pod mounting varlib MySQL to store its data files on that PVC.
Got it.
And finally, there's the whole persistence and management aspect. The data on the PV sticks around based on that reclaim policy we set earlier. Delete means where the PVC goes, the underlying storage volume gets automatically wiped too. Clean up. But retain means the volume, the PV, sticks around even if the PVC is deleted. The data's still there.
Which could be useful maybe for recovery or reuse.
Exactly. Critical for things like database backups or important state you don't want accidentally deleted.
Okay, let's quickly recap those key pieces inside a storage class, just for clarity for everyone listening. You've got the provisioner, that's the software, the driver, that actually creates the storage volume, like ebs.csi.agis.com or GEE-PD. Then the parameters, those are specific settings for that storage type, SSD versus HDD, maybe IOPS settings, zone information, encryption.
All the knobs and dials for that specific storage type.
Right. Then the reclaim policy, super important. Delete or retain. What happens to the PV when the PVC is gone? And lastly, a cluster can have a default storage class. If a PVC doesn't ask for a specific class, it gets the default one. Makes things even simpler sometimes.
Yeah, simplifies the basic use case. And, that brings us back nicely to that analogy from the sources. Storage classes are like automated storage vending machines in Kubernetes. It really captures it, I think. Developers request what they need via a PDC, pick from the menu of storage classes, and Kubernetes automatically delivers the right kind of PV. It just makes managing persistent storage so much easier, more scalable, flexible, really essential for any stateful app like databases or file systems.
So you've hopefully seen now how Kubernetes storage classes take this really quite complex job of managing persistent storage and turn it into something automated, flexible, scalable. It feels like a genuine shortcut to understanding how modern apps handle their critical data.
Yeah, and this ability to abstract things away, to automate. It's not just a tech detail, is it? It genuinely frees up developers, frees up administrators, lets them focus on building stuff, innovating, not just constantly wrestling with the underlying infrastructure pieces. It makes complexity manageable.
So here's a final thought to leave you with. If automation like storage classes can simplify such a core piece of infrastructure so dramatically, what other areas of application deployment, feel ripe for similar transformations? And maybe how could that shape the future of cloud computing for you? What really stands out to you from this deep dive?